Our story begins not in a kitchen, but in a top-secret British laboratory during World War II. The year is 1940, and physicists are perfecting a device called the cavity magnetron. This wasn't for cooking, it was the heart of powerful radar systems, crucial for detecting enemy aircraft. Little did they know, this piece of military tech held a delicious secret.
Welcome to Unboxed Origin, the place where everyday things reveal extraordinary beginnings.
Fast forward to 1945, at the American defense contractor Raytheon. A self-taught engineering genius named Percy Spencer was working on a live magnetron. As he tinkered, he noticed something peculiar. A chocolate bar in his pocket had completely melted. His scientific curiosity was immediately piqued. He then tried popcorn kernels. They popped. Then an egg, which, well, it exploded. Spencer had stumbled upon a revolutionary new way to cook using microwave energy.
Two years later, in 1947, Raytheon unveiled the first commercial microwave oven, the Radarange. But forget what you know about today's sleek countertop models. This was a true beast, nearly 6 feet tall, weighing a staggering 750 pounds and costing around $5,000. That's over $70,000 in today's money. It was water-cooled and designed for industrial use, like restaurants and ocean liners. Clearly not for your average home.
(1955), first attempt at a home model. Tappan introduces the first model intended for home use. However, at $1,295, over $15,000 today, it's still far too large and expensive for the average family. 1967, the countertop revolution. Amana, a division of Raytheon, releases the RR4 Radarange. At an affordable $495, this compact countertop model is a massive hit and marks the true beginning of the microwave's home adoption. 1975, the tipping point. Microwave ovens outsell gas ranges. Mass production, especially of cheaper Japanese magnetrons, and a societal shift towards convenience makes the microwave a mainstream success. 1997, a kitchen necessity. Adoption reaches its peak, with over 90% of all American households owning a microwave oven. It has transitioned from a novelty to an indispensable appliance. 2020. The smart era. Modern microwaves evolve with smart features like Wi-Fi connectivity, sensor cooking that automatically adjusts time, and multifunction capabilities like air frying.
How it works, the energy journey.
Inside the magnetron, how microwaves are born. The magnetron is the heart of your microwave oven, a powerful vacuum tube that transforms electricity into electromagnetic energy. 1. Electron emission. The central cathode heats up and releases a stream of electrons into the surrounding vacuum. 2. Spiraling motion. A powerful magnetic field perpendicular to the electric field causes the electrons to spiral outward toward the anode instead of moving in a straight line. 3. Microwave generation. As these spiraling electron clusters pass the resonant cavities in the anode, they induce high-frequency electromagnetic oscillations, in other words, microwaves. 4. Output. These microwaves are extracted via an antenna or output port from one cavity, then directed into the waveguide that feeds the oven's cooking chamber. How microwaves interact in the cooking cavity. Microwaves don't just bounce around randomly. They follow a brilliant pattern to heat food from the inside out. 1. Entry. Waveguide delivery.
Microwaves are precisely guided from the magnetron into the oven cavity via a waveguide, a narrow metal tunnel that directs energy efficiently into the chamber. 2. Reflection, energy trap. The oven's polished metal walls act like mirrors, causing the microwaves to reflect and bounce repeatedly. This traps energy inside the cavity, creating complex standing wave patterns that energize the space. 3. Penetration, through the container. Microwave-safe materials like glass, ceramics, and most plastics allow the waves to pass through nearly untouched, ensuring the energy reaches the food itself, not the container. 4. Absorption, heating begins. The magic begins when microwaves encounter polar molecules, especially water, fats, and sugars, in the food. These molecules absorb the energy and begin to vibrate rapidly, producing heat internally. 5. Distribution, the turntable effect. Because standing waves can cause hot and cold spots, the turntable rotates the food, moving it through regions of high and low microwave intensity. This rotation helps cook the food more evenly. The dielectric heating process. 1. Polar molecules. Food contains polar molecules like water, fats, and sugars, which have a positive and negative end, acting like tiny magnets. 2. Oscillating field. The microwave oven generates an electric field that rapidly alternates its direction, billions of times per second. 3. Rapid rotation. These polar molecules try to align with the constantly changing electric field, causing them to spin and flip back and forth at an incredibly high speed. 4. Molecular friction. This rapid, agitated movement creates friction and collisions between the molecules. 5. Heat generation. The kinetic energy from this friction is directly converted into thermal energy, which is the heat that cooks your food. Microwave cooking, myth versus fact. Understanding how microwaves truly heat your food. The common misconception is that microwaves penetrate and heat the food uniformly from its very core. Microwaves penetrate only about 1 to 1.5 inches. For thicker foods, the center cooks via conduction from the heated outer layers. Why this matters? Understanding this distinction is crucial for safe and effective microwave cooking. For large or dense items, allowing standing time or stirring or flipping can help ensure heat distributes evenly throughout the food, preventing cold spots and ensuring proper cooking.
Microwave cooking, radioactive myth versus heat fact. Separating science from common misconceptions about your microwave. A common fear is that microwave radiation somehow contaminates food, making it unsafe to eat. Microwaves are non-ionizing radiation, like radio waves. They simply transfer energy as heat. They cannot alter food at an atomic level. Unlike X-rays or gamma rays, which are ionizing and can remove electrons from atoms, potentially causing damage or radioactivity, microwaves only have enough energy to cause molecules to vibrate. This vibration is what generates heat, and once the microwave oven is off, there is no residual radiation or change in the food's atomic structure. Why microwaving can be better for nutrients. Many vitamins, especially water-soluble ones like vitamin C and B vitamins, are sensitive to heat and can leach into cooking water. Since microwaving often uses less water and cooks food more quickly, the exposure to these nutrient-degrading conditions is minimized. This means that, contrary to popular belief, microwaving can be a nutritionally superior cooking method for many foods. What other everyday items do you want us to unbox the origin of? Let us know in the comments below. Don't forget to like this video and subscribe to Unboxed Origin for more fascinating stories behind the things you use every day.